In this video, we're going to solve the 2021 American Computer Science League Finals Intermediate 1 problem. So this one was sentences. And it's basically just a simulation problem. And we'll take a look at the problem, we'll write some stuff out, test some inputs, and get outputs, and then we'll code this out. So let's just read what we have here. So given a dictionary of words and sentence structure, we're going to generate sentences of that structure using words from that dictionary. Alright, so basically we'll be provided a dictionary, it'll have some stuff in it, and that stuff is going to be described in the next part of the problem statement. So let's move on. The dictionary of words is a set of strings. So each string starts with a capital letter indicating a part of speech, followed by a list of words. The parts of speech are noun, command, verb, adjective, adverb, and preposition. So these are the different types of parts of speech we're going to use. And each word is only going to consist of lowercase letters, and words are going to be separated by a single space. So as the problem statement was saying, we begin the string with a capital letter. So that's going to indicate our part of speech. So like we have a B here or a J here. So those would be adverb and adjective respectively. And then we're going to have our strings that fall under each of those categories. So like with adverb, we have productively, and with adjective, we have green. And then with other ones, like maybe noun, we have multiple words, and those are going to be separated by spaces. So we have apple, trees, and birds. So those all compose of our dictionary. Now, in addition to this dictionary, according to the problem, there are only 3 articles in the English language, a, an, and the. And we're not going to include any of this into the dictionary, because dictionary, I guess, is just going to contain our part of speech. But we're going to use an a for the words a or an, and a t for the word the. Alright, so I guess whenever we see an a or a t, we're going to substitute with one of those two. Now the word an is used if the next word begins with a vowel, and the word a is used otherwise. So that tells us we're going to have to implement some sort of a condition to check for that. Next, we have the types of sentences. So we have declarative sentences. They state information. That part's irrelevant because the next part says they end with a period. Alright, so that's important. Imperative sentences give commands, and they end also with a period. Now interrogative sentences ask questions. So these are going to end with a question mark, and they're also going to begin with what. So we'll have to have some sort of prefix and suffix. And then exclamatory sentences express emotion and end with an exclamation mark. So this one only has that suffix. Alright, so the next part says the sentence structures are strings of capital letters identifying the type of sentence described above, followed by the part of speech code for each word in the sentence. When using the words in the dictionary, wrap around to use the first word again for that part of speech when the list of words is exhausted. Multiple sentences can be generated by separating each of them with a single space. All sentences that are generated must start with a capital letter. Alright, so what that paragraph basically means is that when we have something that looks like this right here, so we see that we have E, T, J, and so on and so forth. So that's telling us that the first character in each of these, so these are all space separated. So we'll have a space separated here, here, and here. So for each of those phrases, it's going to start with a D, I, Q, or E. So that'll just tell us the type of sentence. So it'll say if it's declarative, imperative, interrogative, or exclamatory. And then the paragraph is telling us that for the rest of the characters in the phrase, we're just going to use the part of speech code for that. Or if it's a T or an A, we're just going to use those articles as we need to. Alright, and then we have the paragraph on input. So it tells us about our input. So we're going to have the first line of input be the number of parts of speech. So that'll be helpful when getting our input. And this is going to be followed by many lines of strings. So as it said before, each line starts with a capital letter, followed by words in all lowercase letters. And then last line of data will be a string representing the sentence structure for that output. So it looks like here that we have the first N or so lines in our input that are going to be the things that we put in our dictionary or our parts of speech or whatever. And then that last line of input is going to represent the actual sentence or multiple sentences. So it looks like each of these space-separated phrases are going to be their own sentence. And so we can see in the output here we get the green apple grows productively on the tree. What birds fly above? The green apple grows below a green tree among birds. Pick an apple. So here we're going to go through each of these phrases and see how they map to the respective output. So let's start with the first one. Alright, so the first thing that this has is an E. So that's going to tell us it's exclamatory. So it's going to end with an exclamation mark. So we have to remember that. Now next we have T. So that's always going to be a the. And then next we have J. J is an adverb. And here we have an adverb that is green. So we'll write green here. And next we have N. And so N is going to be a noun. So the way this works, if we have multiple nouns or multiple of any parts of speech, is that I'm not sure if the problem statement clarified this here, but it looks as if, according to the output, it looks as if every time we use a noun, or every time we use a certain part of speech, the next time we want to use that part of speech, we're just going to use the next available part of speech. So if we've used apple, then next we're going to use tree. And if we use tree, next we're going to use birds. And if we've used birds, then we're going to go back and use apple. So it'll go like apple, tree, birds, every time we see those sequences of n's. So getting back to our sample input here, we have E, T, J, and now we're on N. So N is going to start off with apple, so the green apple. And next we have V. So V is going to be grows. And now the next character we have is B, so that's going to be an adverb. So our adverb that we have here, it's only one, we have productively. And then we have a P. Well, a P is a preposition. So we're going to start off by using on. So we've used on here, so on. And now we have another T. That's going to be just the. And finally, we end with another noun. So if you recall, we've used a noun already. We've used apple here. So the next noun we're going to use is not apple, but tree. So productively on the tree. So now that we've gone through this entire sequence, we have to remember that we began with an E. So we should end with an exclamation mark because this should be exclamatory sentence. So we'll just put an exclamation mark here. So that'll be the end of this phrase. And next we move on to Q and VP. So Q tells us that we have an interrogative sentence. So this is going to ask a question. So we have to begin with what and end with a question mark. So we'll say what, and then our next character is N. So we're going to need to use a noun. Well, if we look at our nouns, we've used apple and tree. So the next one is birds. So we'll say what birds. And that brings us to V. V is for verb. So we've used grows. So we'll use fly now. Fly was next, so we'll use fly. And then we have P. P is a preposition. So we've already used one preposition. That was on. So the next one is above. So what birds fly above? And that was the end for this phrase. And we have to also end with a question mark because this was an interrogative sentence. And now we can move on to the third phrase. So the third phrase is D, T, J, N, V, P, A, J, N, P, N. So this starts with a D. This tells us that this is a declarative sentence. And this is going to state information, so we're going to end with a period. So next we have T, that's just going to be the. And then we have a J, well that's an adverb, and we only have one adverb, so we're just going to use green again. Next we have to use a noun, because that's N, and so we've already used apple, tree, and birds. So the last one we used was birds, so we're just going to cycle back again and use apple. So the green apple. Next we have a verb, which is V, and for our verbs we only have grows and fly. Well, the last verb we used was fly, so the next verb we're going to use is grows. Then after that, we have a preposition. So if we look at our prepositions, we have 4 prepositions. We've used on and above, so next we're going to use below. So the green apple grows below. And next we have the letter A. Alright, so this is the first time we're seeing the letter A. So because the letter A either gives us an A or an N, we need to determine whether the next word that we're going to put in the sentence is starting with a vowel. If it starts with a vowel, we need to use an, because that's what it said right here. So we look at the next word, and that's going to be J. So J is an adjective. So that's green. Well, green begins with a G. G is not a vowel. So we're going to use just A here. So below A. And then the next one is green, as we saw there. And next we have a noun. So the last noun that we used was, if we look at our nouns, we've used apple, tree, birds, and then we went back to apple right here. And so the next one is going to be tree. So below a green tree. And then after that, we have a preposition. So the preposition is going to be among here. And we finally end with a noun. So the last noun we used was tree. So we're going to use birds now. So among birds. And we have to end with a period just like I've put here because this was a declaration. This was a declarative sentence. And finally, the last phrase is going to be ICAN. So we'll write that down. So I tells us that this is an imperative sentence. So according to the rules, imperative sentences give commands. They have to end with a period, just like declarative sentences. So we'll just keep that in mind. Next, we have a C. Well, C is going to be a command. And our command has only pick in it. So we're going to use pick. And then we have A. Well, A depends on whether the next word is going to begin with a vowel or with a consonant. So the next character here is a noun, so we have to look at our next noun. Well, if we look at our list of nouns, we've used apple, tree, birds, and then apple, tree, birds, and we left off on birds right here. So we're going to use apple next. So because apple begins with an A, that means it begins with a vowel. So we have to use an before it. So pick an apple. And finally, we have to end with a period because this was an imperative sentence. And that's all that we have here. So once we have all this, once we have all these sentences, we can just combine them together and put them all on the same line, separated by spaces, and we should get this output right here. And if we look at it, we get the green apple grows productively on a tree. What birds fly above? The green apple grows below a green tree among birds, and pick an apple. So it looks like we got all that right. So just like we walked through here, it's basically a simulation problem. All we have to do is check every character, and every time we see a certain character, we have to make some decision on it. So let's go ahead and implement this in code. And as we code this out, I'll explain how each of the parts of the code are going to contribute to the final solution. So here we just have our starting code. So we have our empty function. ACSL called generate sentences, and it brought two parameters, dictionary and sentences. So a dictionary is going to be the dictionary of those parts of speech that we can use, and then the sentences are going to be that one line of characters that we're going to process. So if you look here, we also have from lines 4 to 11, I just wrote down the sample input that we worked with before, just so then we can test out our function with this input. In addition to that, just to show you that this is going to work for all the test cases that ACSL gave for this problem, I've created a small script that's going to run around 13 tests on all those 13 inputs and compare them to the correct outputs. So we'll see that our function passes for all of them. So we can start this by, on line 2, we're going to create a dictionary, an actual Python dictionary, that's called parts of speech. So parts of speech. And the purpose of this dictionary is to store our parts of speech. That's basically it. So we're going to have n, and I'll just leave this blank for now. And then we're going to have C, that represents our command. So we have noun and command. And then we have V for verbs. And then we have J for adjectives. We'll put a comma there. And then we have B for adverb. And finally, we have P for preposition. So these are all our parts of speech. And then we're also going to maintain a separate dictionary that contains our types of sentences. So those could be declaration, interrogation, imperative, or exclamatory. So we'll get to that in a second. Let's figure out what we're going to do for the values for each key in parts of speech. So here for each value, we're actually going to store a list that contains the first item as the list of the different words that fall under that respective part of speech. But then the second item is going to maintain the current word that we're going to use next, if we happen to use that particular part of speech in our sentence. So if you remember when we were writing out our examples, every time we used, let's say, a noun, we had to use the next noun in that cycle. So we had to go from apple to tree, and then to birds, and then back to apple, and then to tree again, and birds, and so on and so forth. So we just had to keep cycling like that. And if we create the second element to represent the current word that we're going to use, that'll help us to constantly make sure that we're not always using the same noun and that we're modifying it appropriately. So here, our first value, that's going to be for noun, we're going to set it equal to a list where the first element is, let's just call it an empty list, because we're going to populate that afterwards. So an empty list and then 0. 0 represents the first item in our list of parts of speech. So just like we created this list for nouns, we're just going to copy it over for every single one of these. So I'll just take this and copy it and then paste it here, 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 and here. And we can actually get rid of this comma. Now that we have this dictionary, we want a second dictionary. That's going to be called types of sentences, or types of sentences. It's just going to contain those 4 different types of sentences that we talked about earlier. So we'll call this types sentences, and we'll set that equal to another dictionary here. And we'll say D represents, so we're going to have a list here, and this we actually know what the elements are. So here for each of these keys, the value is going to be a list that contains the first item as the prefix and the second item as the suffix. So if you remember with the different types of sentences, we could begin with something, and that would be our prefix. And then we could also end with something in our sentence. That would be our suffix. Now with all the types of sentences that we have here, they all have a suffix, but not all of them have a prefix. So for the ones that don't have a prefix, we're just going to put an empty string. But for the ones that do have a prefix, so I think that's only the question one, we're going to put a what for our prefix. So here, declaration had a prefix of nothing, and then a suffix of a period. And then after that, the imperative had a prefix of nothing again, and also a suffix of a period. And then after that, we had a question, so interrogative, Q. And this had a prefix of what. And here we're actually also going to put a space here, because when we combine our prefix and our suffix later with the actual sentence, we don't have to go through adding that second space there, or that space in between, so we'll just put a space here. And then what, and then our suffix is going to be a question mark. And then finally we have our exclamatory. So that'll be E is going to have a prefix of nothing and a suffix of an exclamation mark. All right, so now that we have these two dictionaries, we can process our data. So the first thing is that we want to separate our items in our dictionary and sort of parse through those so then we can add all of those that are necessary to our parts of speech. So the dictionary is going to basically be a list containing strings. So this will be a string, this will be a string, this is a string, this is a string, and so on and so forth. So we want to say for each of those lines in the dictionary, so for line in dictionary, we will add that to our parts of speech list. So we'll say parts of speech, and then the key we're going to use is going to be the very first character in that line. So that'll be line bracket 0. And then we want to set the first index of the list value of this particular key, so 0, equal to line at 2 onwards dot split at a space. That's basically saying that we're going to take everything that's this character onwards or this character onwards, so on and so forth, and we're going to split it at a string. And that'll generate a list containing those individual words. Now, after we have this, we can just say that phrases is equal to sentences.split. So that's basically saying that we're going to split all of these individual phrases into a list of, in this case, 4 phrases. That way it'll be easier to construct our sentences. And once we construct our sentences, we're going to group them all back together, separated by spaces. So let's call our list of sentences that we generate answers. So answers is equal to currently a blank list. And then we're going to use a loop to loop through all of these. So we'll say for phrase in phrases. And so that's going to go from here. So we'll read this one, and then we'll read this, and then this one, and then this one. So that's what we're looping through. And for each phrase, we're going to start off by creating 3 variables. So we'll have string blocks, prefix, and suffix. So this is equal to an empty list, an empty string, and another empty string. So what do these 3 variables mean? Well, the way we're going to implement this particular part of the algorithm is that for a particular phrase, we're going to create a list that contains the individual words that we're going to need in order to construct the sentence. So string blocks in the end is going to look like a list that contains, if we're going to take this example, it's going to look like a list that contains the individual strings, the, green, apple, gross, productive, and so on and so forth. And then what are prefix and suffix? Well, prefix is going to be the prefix of our sentence. So if we add anything that goes before our sentence starts, for example, what, then that's what we want to add to our final string at the beginning. And then at the end of the string, we want to add a suffix. And so the suffix is going to be one of these 4 items right here. So it could be either 2 periods, a question mark, or an exclamation mark. Now that we have these 3 variables, we can create another for loop. So we'll say for index car and enumerate phrase. So what exactly are we doing here? Well, we're going through every index and character in any particular phrase. So if we take ETJ and VBPTN, we're basically saying for index and character in this phrase. So we'll have 0 in E, and then 1 in T, 2 in J, so on and so forth. And so this is going to help us actually process those individual characters and convert them to the correct words that we need to use in our phrase. So for index and character in enumerate phrase, the first thing we're going to do is make a conditional check. So we'll say if the index is equal to 0, and we'll just also add an else here. So why are we doing this? Well, the very first character, if we look here, the very first character of any phrase is going to be an E, Q, D, or I. And that's going to tell us the type of sentence we have. It's always going to be like that. So if we know the type of sentence, then we know what we're going to assign for our prefix and our suffix. So we'll say prefix and suffix is equal to types sentences at the particular character and at index 0, because that's the prefix. And then the suffix is going to be at the same value here, except index 1. So that was pretty straightforward. Now we're going to get to the more complicated part. So if we're not at index 0, that means we're actually creating our words from our phrase. So under this else right here, we're going to start off with another condition. So we're going to say if car in parts of speech. Now, why are we making this conditional check? Well, we can identify that there are different types of characters. So there are certain characters like B, J, N, C, V, P that are going to mean that we have a part of speech. And then there are other characters like T and A, which are going to indicate that we're using some sort of article. So we're using the, a, or an. So here, if we're using a part of speech, then we want to do some particular thing. So let's address that particular thing. So if the character is in parts of speech, that means if it's one of these 6, then we are going to say that string blocks dot append. And here's where the syntax gets a little verbose, but we're going to say parts of speech at that particular character. And then we're going to say bracket 0. So let's say that we're at this J right here. So we're going to go to J, and we're going to say that we want this first item right here. And inside this first item, so this first item is the list. And inside this list, we want to access parts of speech, bracket car, bracket 1. So what does that mean? Well, this indicates that we are now accessing parts of speech at this character. So that's this list right here. And the first index, so we're accessing the 0 or whatever number this could be. So this is going to represent our index because it's going to tell us what word we want at that moment. Now, once we append this to our string blocks, we need to modify this particular value that we have right here because we need to make sure that we don't reuse the word again in a row. So we'll say parts of speech at car 1 is now equal to whatever it was before. So parts of speech at car 1 plus 1. And then we're going to do mod the length of parts of speech at car at 0. So this is a little modulo trick that we use to create a sort of circular indexing. And so every time we append that new word, we're going to increase our counter. So now we're actually indexing the next element. But if we go above the length, then that means we want to circle back. And that's what this modulo helps us do. So now we are finished with this condition. Now we need to make an elif condition. So elif car is equal to A. So if the character is equal to an A, that means we are going to add either an A or an N. So we need to do a nested if statement in here. So we're going to have to actually check the next character. So next car is equal to phrase at index plus 1. And here you might be concerned about whether index plus 1 is actually going to be a valid index. Well, these are all actual English sentences. So you're never going to end an English sentence with an A or with an N. So here we're perfectly fine with just getting this at this index. Now we're going to make a conditional check here. We'll say if parts of speech at next car at index 0. So again, that's going to get whatever list is right here. So maybe this list or this list or this list, depending on what that next character is. And if that at parts of speech next car at bracket 1. So right here we have basically, we are getting that particular word that we might add next. And then that word we're adding next, we need to check that first character. So bracket 0. And if that is in A, E, I, O, U. So if it's a vowel. And if it's a vowel, then that means we have to append an. So string blocks dot append an. Otherwise, we are going to append a. So string blocks dot append a. And it's actually really straightforward like that. So that wraps it up for this condition, and we can make a final else clause. So else. If it's else, that means the only character that we could have here is a T. And if it's a T, that means we're just adding the. So string blocks dot append the. And that covers the brunt of the work that we have to do. So all that's there remaining is to actually combine these phrases together into a sentence, and then combine the sentences together and separate them by spaces. So after this loop, we're going to say sent is equal to prefix plus space dot join string blocks plus suffix. So that's going to create our sentence for us. And then if you notice what all we've done here, we haven't actually capitalized that first character. So we need to make sure it is capitalized. So we'll update sent. We'll say sent is equal to sent bracket 0 dot upper. So uppercase the first character, and then plus the rest of it, sent 1 onwards. And that should create a syntactically correct sentence. And we can add that sentence to our answers. So answers.append sent. And once we've created our sentence, once we've added it to answers, and once we've done that for all the phrases, we can return a joint string containing all those answers, all those sentences separated by spaces. So we'll just say return space separated answers. So space.join answers. And that's all that we have to do here. It was actually really straightforward, just a simulation problem. And now we can test out our code. So let's go to the bottom. And we have our sample input here. Let's test this out with our sample input first. So in order to do this, we'll just say lines is equal to sample input dot split at new lines. And then we'll say n is equal to int lines 0. That'll get us the number of parts of speech that we're using here. And then we'll also create another list called dictionary. So dictionary is equal to a blank list. And then we'll say for I in range 1 to n plus 1. And so that's going to loop through these indices. And we'll say dictionary.append lines at I. Once we have that, we can just say sentences is equal to the very last line in our sample input, or in our lines list. So lines at -1. And finally, we can run our function. So we'll just say print generate sentences using our dictionary and our sentences. All right, let's go ahead and run this. So we see in the side that we get the green apple grows productively on the tree with an exclamation mark. What birds fly above with a question mark. And then the green apple grows below a green tree among birds, period. Pick an apple, period. And it looks like our code was successful here. So let's run this against the tests that I've created earlier. So I'll just comment all this out because we don't need it here. And in order to run the test, all I have to do is say import sentences tester. So let's run this now. And we see that all the tests have passed. So it looks like our code was successful. All right, so that's it for this video, and I hope this was helpful.